हमने जो है पिछले लेक्चर में अम्पोलंग कंसेप्ट डिस्कस किया था और अम्पोलंग कंसेप्ट में फर्स्ट अम्पोलंग रिएजेंट 1,3-डाइथाइन डिस्कस किया था। ओके, अम्पोलंग कंसेप्ट किसे कहते हैं, उसका यूज कैसे करते, और अम्पोलंग कंसेप्ट का जो फर्स्ट रिएजेंट देखे हमने 1,3-डाइथाइन, उसकी प्रिपरेशन और उसका यूज हमने पिछले लेक्चर में डिस्कस किया था। ओके, आज जो है हम सिंथेटिक एप्लीकेशन डिस्कस करेंगे अम्पोलंग कंसेप्ट के बाय द यूज ऑफ 1,3-डाइथाइन अम्पोलंग रिएजेंट। ओके, सिंथेटिक एप्लीकेशन ऑफ अम्पोलंग कंसेप्ट बाय द यूज ऑफ 1,3-डाइथाइन reagent. Okay, so near about there are 4 application of Upolung concept by the use of Upolung reagent. The first application is formation of new CC bond. Okay, this is the first application of Upolung concept by the use of Upolung reagent 1,3-diethane, formation of new carbon-carbon bond. Okay, in the previous lecture I had discussed how to prepare new CC bond. Okay, the new CC bond is prepared by the reaction of lithiated salt with any alkyl halide. Okay, by the reaction of lithiated salt with any alkyl halide. Okay, we know that how to prepare lithiated salt. Now look here, firstly we will prepare 1,3-diethane reagent. Okay, we know that when any carbonyl compound treated with 1,3-diethiol to generate 1,3-diethane. Okay, so here we will write formaldehyde. Okay, this formaldehyde treated with firstly with 1,3-diethyl. Okay, this is 1,3-diethyl. Okay, it reacts with each other. Here water molecule will be removed and we will generate 1,3-diethane. Okay, this is the structure of 1,3-diethane. Okay, by the reaction of formaldehyde and 1,3-diethiol, water molecule is here as a leaving group. Okay, this is our Upolung reagent. Okay, this 1,3-diethane further react with N-butyl lithium. We know that N-butyl lithium is a strong base and it extracts one proton from 1,3-diethyl to generate lithiated salt. Okay, we know that here halide consists positive charge and Bu consists negative charge. So this Bu extracts this proton, due to which lithiated salt will be generated. Okay, this proton is attracted by Bu negative, so here this bond shifted toward the carbon and carbon pair of positive negative charge. Okay, here Upolung also observed, because of here the carbon of 1,3-diethane initially contain partially positive charge, but after the reaction of 1,3-diethane with N-butyl lithium, this charge converted into negative, this charge carbon converted into negative charge. Okay, so here Upolung concept is of after the formation of lithiated salt. Okay, this is the lithiated salt. These lithiated salt react with any alkyl halide to form a new CC bond, new carbon-carbon bond. Okay, suppose here I am taken ethyl bromide. Okay, this is the structure of ethyl bromide. this negative charge carbon act as a nucleophile and it attacks on this CH2 group, and simultaneously here bromine will be removed, and this LiBr is removed as a byproduct. Okay, and this carbon is bonded with this carbon. Okay, so we will generate this type of product. Okay, here one hydrogen is present and this carbon is bonded with this carbon atom. Okay, CH2 CH2. Okay, when we observe the structure of alkylated 1,3-diethane, this is the alkylated 1,3-diethane, and here this one new CC bond will be generated. Okay, so here one new CC bond will be generated. Okay, after the formation of this alkylated 1,3-diethane, it reacts with HgCl2 in presence of water. Okay, and to form our final product, aldehyde. Okay, and the byproduct is 1,3-dithiol plus HgOH twice. Okay, so this is our final product aldehyde. Okay, basically the main point is here only to form a new CC bond. Okay, here new carbon-carbon bond will be generated. So this is the first application of Upolung concept by the use of 1,3-diethane Upolung reagent. Okay, now the second application is formation of dicarbonyl compound. Okay, this is the second application of Upolung concept by the use of 1,3-diethane Upolung reagent, formation of dicarbonyl compound. Okay, so dicarbonyl compound is prepared by the reaction of lithiated salt with acid halide. Okay, by the reaction of lithiated salt, with acid halide. Reaction of lithiated salt with acid halide to produce dicarbonyl compound. Okay, now look here. Firstly, we will prepare lithiated salt. We know that formaldehyde is treated with 1,3-dithiol to produce 1,3-diethane Upolung reagent. The Upolung reagent 1,3-diethane further react with N-butyl lithium stock base to produce our lithiated salt. Now look here. This is our formaldehyde. Initially it treated with 1,3-dithiol. Okay, this is the structure of 1,3-dithiol to produce 1,3-diethane. Okay, this is the 1,3-dithiol. Okay, here this carbon is partially positive. Okay, this and 1,3-dithiol further treated with N-butyl lithium to produce lithiated salt. Okay, treated with acid halide. Okay, here I am taken acetyl chloride. Okay, this is the acid halide. Okay, lithiated salt treated with acetyl chloride, acid halide to produce our final product, dicarbonyl compound. Now look here, this negatively charged carbon attached on this carbonyl carbon. The bond between new bond formed between carbon and this carbon. So the pi bond between carbon and oxygen shifted toward the oxygen, and we will get this type of product. Okay, here one proton is present. This bond bonded with this carbon atom. Okay, so here bond formed between this carbon and this carbon, due to which this pi bond shifted towards the oxygen. So oxygen, they are positive negative charge. Here one methyl group is present, and here Cl group is present. Okay, so we will generate this type of intermediate product. Okay, after that this negative charge shifted toward the in between oxygen and carbon. So here Cl is removed, and we will get this type of intermediate product. Okay, here Cl will be removed. Okay, after this formation of intermediate product, this intermediate product undergoes amalgamated hydrolysis to produce our final product, dicarbonyl compound. Okay, see here two carbonyl compound is present, so it is dicarbonyl compound. Okay, so these are the byproduct is 1,3-dithiol and HgOH. Okay, this is the byproduct. Our main product is dicarbonyl compound. Okay, so this is the second application of Upolung concept by the use of Upolung reagent 1,3-dithiene. This is the formation of dicarbonyl compound. Second application. Now the third application of Upolung concept by the use of Upolung reagent 1,3-dithiene is formation of BetaHydroxy carbonyl compound. Third application. Formation of BetaHydroxy carbonyl compound. Okay, the BetaHydroxy carbonyl compound is prepared by the reaction of lithiated salt with unsymmetrical epoxide. Okay, now listen carefully. BetaHydroxy carbonyl compound is prepared by the reaction of lithiated salt with unsymmetrically epoxide. Okay, so firstly we will prepare lithiated salt. Okay, we know that when aldehyde is treated with 1,3-dithiol to produce 1,3-dithiene, 1,3-dithiene undergoes deprotonation with a strong base N-butyl lithium to produce lithiated salt. salt further treated with unsymmetrical epoxide to produce our desired product. Beta hydroxy carbonyl compound. Now look here. This is our formaldehyde. Okay, is treated with 1,3-dithiol to produce 1,3-dithiene. Okay, this 1,3-dithiene further treated with n-butyl lithium to produce lithiated salt. Okay, this is the lithiated salt. Okay, this lithiated salt treated with unsymmetrically epoxide. Now look here. Okay, this is the symmetrical epoxide. Okay, and now this is unsymmetrical epoxide. Okay, so this negative charge carbon ion of lithiated salt attack on this carbon atom. Okay, due to which these bonds shifted toward the oxygen. Okay, and we will get this type of intermediate. Now look here. Okay, here one proton is present. Okay, this negative charge is bonded with this carbon atom. Okay, so here new CC bond will be generated. Okay, and this carbon is bonded with this carbon atom. Okay, and this carbon atom bonded with this oxygen. Okay, and this bond shifted toward the oxygen. So oxygen bear negative charge, and this carbon is bonded with this carbon. Okay, so we will generate this type of intermediate product. Okay, after the formation of this product undergoes amalgamated hydrolysis in presence of HgCl2 and water. Okay, to produce our final product. This is the alpha carbon atom, this is the beta carbon atom, and at beta position hydroxyl group is present. So it is called as BetaHydroxy carbonyl compound. BetaHydroxy carbonyl compound. Okay, this mechanism of conversion of this compound into beta hydroxy carbonyl compound is same when we see in the previous lecture. Okay, this is amalgamated hydrolysis. We will see it in the previous lecture. Okay, and byproduct is 1,3-dithiol and also HgOH2. Okay, this is the byproduct, but our final or desired product is beta hydroxy carbonyl compound. Okay, firstly, what will be happen here? The lone pair of sulfur is attacked on Hg, so here Cl will be removed. Okay, after that this lone pair of sulfur shifted in between this carbon and this carbon, so here pi bond will be generated. Okay, and due to which this bond shifted toward the positive charge sulfur atom, and after that hydroxyl group attack to form our final product beta hydroxy carbonyl compound and byproduct 1,3-dithiol and HgOH2. Okay, so this is the formation of beta hydroxy carbonyl compound. This is the third application of Upolung acid by the use of Upolung reagent 1,3-diethane. Okay. Now the last and fourth application of one Upolung concept is formation of alpha-hydroxy compound. Alpha-hydroxy compound. Okay. So alpha-hydroxy compound is prepared by the reaction of lithiated salt with aldehyde or ketone. Okay. Now listen carefully. Alpha-hydroxy compound is prepared by the reaction of lithiated salt with aldehyde or ketone. Okay. We know that when formaldehyde is treated with 1,3-diethyl to produce 1,3-diethane, 1,3-diethane undergoes deprotonation with the help of n-butyl lithium to produce lithiated salt. Okay, so this is the same step in all reaction. After that, this lithiated salt treated with this aldehyde. Okay, so what will happen here? This negative charge of lithiated salt treated with this carbonyl compound, due to which this pi bond shifted toward the oxygen, and we will get this type of intermediate product. Here new CC bond will be generated. Okay, so this pi bond shifted toward the oxygen, so oxygen there positive negative charge, and this is as same. Okay, after the formation of this intermediate product undergoes amalgamated hydrolysis. Okay, to produce our final product. Alpha-hydroxy carbonyl compound. Now look here, this is our carbonyl compound function group. This is alpha carbon, and alpha carbon contain one hydroxy group, so this is alpha-hydroxy carbonyl compound, and byproduct is 1,3-diethyl and HgOH2. Okay, this is the byproduct, but our desired product is alpha beta-hydroxy carbonyl compound. So this is all about the synthetic application of Upolung concept by the use of Upolung reagent 1,3-diethane. Okay, there are 4 applications. First is formation of new CC bond. Second one is formation of dicarbonyl compound. Third one is formation of beta-hydroxy carbonyl compound, and fourth is formation of alpha-hydroxy carbonyl compound. I hope you will be understand better. If you have any problem regarding to this topic, you can ask me personally. Okay.